this line. I can write J is equal star intptr. What does this mean? Let's first start from the first lines. First, we declare two variables, I and j, right? Assuming that this is j. So this is address of I and this is j. J is 0 and I is 5, right? So I is 5, the first two lines. And then what I did, I declared the pointer, intptr, and this pointer points to I. It's not pointing to j, it points to I, right? That's what I did here. And that's it. Inside my code, now I have a pointer pointing to I. When I write star intptr, is like I'm writing I. That's what I mean, yield to the data object. So writing star intptr in your code is like you are writing I. So which means I want the content. So star means I want the content of memory location addressed by intptr. And the content is basically the I, the value of I. Is this clear? So j is equal star intptr. It means j is equal 1. Oh, sorry, j is equal I. It's like I'm writing this line. This means that the value of j will become 5. So the new value of j will be 5 here. And then what I did, the next line I used again star intptr, which means it's like I'm doing I is equal 100. So the value of I will change to 100. And this is what will happen in this code. And then I put printf. And as you can see, I used here %p. And this is the explanation. So %p can be used in printf call to display a pointer in hexadecimal. So this will give me the address. So %p, it will print or display the value of the address. Of course, I need to put just the pointer here, the name of the pointer. So %p is for intptr and %d is for star intptr or I. This is the same, right? If I write I here or star intptr. So after execution of this code, I will get what will I get displayed is value stored at address, and then this address 0x1000 is 100. The value is 100. Is this clear? I can show you this quickly when we run it. So you can probably let's go to set the display. Oh, God. Right. So I post the code here. You can we can test it quickly on the simulator. I don't have to use the embed board. So this is the code there. This is the same code. So I declared I and j. I declare the pointer. The pointer points to I. And then I did j is equal intptr. And then, sorry, star intptr is like doing j is equal I, and then I did star intptr is equal 100. So I'm changing the value of I, of j, sorry, of I. And then I do printf, so the %printf here. And again, I'm displaying the I and j. I'm displaying the I and j just to see that I will get the same answers, you know, what I was expecting, using pointer or not using pointer. So if I run this, take some time to run. So this is the result. value stored at address, and this is the address reserved for this memory for this variable. As you can see, it is in hexadecimal. Sorry, disconnect. Yeah, is 100 because this is I. I use the star INTPTR, so this is I. And again, when I displayed I here using I, so using star INTPTR or using I is the same. And then J is 5. J has changed here when I used star INTPTR. Now, later on in my code, I can, now what I want to do, I want to change, I want the pointer now to point to J. And I want to change the value of J to 200. And then I want to display it using the pointer. So how can I do this? The pointer was first pointing to I. I want now the pointer to point to J. And then I want to use it to change the value of J to 200, for example, and then display it. What do I need to add to this code?
Star INTPTR is equal to %J.
We don't use the star. Now I need to use the pointer. If I use star INTPTR, it means I'm using I. So I need to use just the name of the pointer. INTPTR. Yes? Equal. So it's similar to this one, right? J. So now I want to use J. Right? Is this what you said, yeah? So if you put star here, it's wrong. If you put star here, it's wrong. Because you cannot do I, it's like you are doing I is equal J. And this is wrong. I doesn't hold an address. I is an integer, and it's not for an address. So star INTPTR is wrong. So you have to use the pointer, the name of the pointer, INTPTR. Is equal, and then I just want to change the value of J using the pointer. So what should I add?
Star and INTPTR is equal to 200.
Good. Star INTPTR is equal 200. Here is like I'm doing J is equal 200, right? Is the same. Now INTPTR points to J. It doesn't point to I anymore. It points to J. And I'm changing the value of J through the pointer. I'm using the pointer that points to J to change its value. And then I can display. I will display both J and I, just to see that I hasn't changed, so I should stay 100. And I'm going to display again J, but using star INTPTR, just to see it's the same. So I can use here star INTPTR. Is this clear? So those two last lines are the same. I should get exactly the same answer. I should put here J is, I can access it using J, or I can access it using star INTPTR. Right, let's run. I don't know if I did some syntax errors. Right, yeah. So I hasn't changed. Do you see the last three lines? I is 100, J is 200 now, and the last one is J is 200. So either using J or star INTPTR is the same. You've seen it, yeah? I think it disconnected again. Is this clear? Yeah, I think it's very simple and it makes sense. Right. Now, as you remember when I talk about the pointer, the type of pointer is very important. So it has to be the same type of the variable that it points to. So the type of pointer specifies how many bytes are read at the address and how they are interpreted. So let's explain this first with the. So if I have a memory and each memory location is 8 bits. So the size of the word is 8 bits. This will depend on the microcontroller that you use. I mean, you can have 8-bit microcontrollers, you can have 16-bit, you can have 32-bit, you can have 64-bit, and this is the size of the memory location, each memory location. Right. When you work with pointers, you don't have to worry how many memory locations will be reserved for each, as long as you use the exact type. And this is why I said it's very important to use the type. So if I have float, for example, x, and I put is equal to 0.95. And then I declare a pointer, float, p, and I will initialize it to x. Float is how many bits? Floating point, single precision. Float is floating point, single precision. Yeah, how many bits?
32.
32. Good. So float